Across the universe, one of the most common objects to find are stars. The sun that we see in the daytime, which is vital to the survival of life on Earth, is a star, just like the stars that we see in the night sky. In our galaxy alone, there are hundreds of billions of stars. Some are smaller than our star, like red dwarfs. Some are bigger than our star, like red giants. And some are much, much bigger than our sun, like supergiants. That's not to say that our sun is a small object. It is not a small object at all. It is massive. It's so huge that it's 300,000 times the mass of the Earth. This is just to say that even with how huge our sun is, there are objects out in the universe that dwarf it in size. Now, with such gigantic objects, it's almost impossible to compare something as small as, say, us to an object like the sun. But there is something we share in common, and that is a life cycle. Our sun and all the stars in the universe have a birth, a life, and a death. In the beginning, stars are born in molecular clouds. Molecular clouds are gigantic clouds of dust and gas out in the universe that are thousands to millions of times bigger than the sun. These gas clouds are also incredibly cold, and that is a very important feature for star development. Due to the cold temperatures of the molecular cloud, the dust and gases come together to form clumps. And these clumps get bigger and bigger over the course of millions of years. Eventually, these clumps of gas and dust form to such a gigantic size that they can pull other clumps of gas and dust into them through a stronger gravitational pull. This forms even bigger clumps of gases and dust. Now, you might be thinking, okay, so what's stopping these clumps of gas and dust to just continue growing forever and just become universe size? Well, eventually, the gravity of the clumps becomes so powerful that the clumps literally collapse in on themselves. When these clumps are collapsing, there is a ton of friction going on. And this friction generates a lot of intense heat. This heat will form a protostar and keep the clumps from collapsing. Now, this protostar will continue to use the heat of its own formation to keep itself from collapsing for millions of years to come. But it can't use this method forever. Eventually, it will run out of this heat. But this does not mean the end of the star. Otherwise, of course, we wouldn't have the sun. We wouldn't have any of the stars in the universe. So what happens next? Well, the star changes its energy output. Instead of using the heat of its own formation, it uses the energy output from nuclear fusion within the star. Nuclear fusion is going on all throughout a star, but we're going to focus on the core of the star. Within the core of the star, there are hydrogen atoms that are literally being squeezed together to form helium atoms. This is nuclear fusion. During this process, a ton of energy is being outputted from the nuclear fusion reaction. This energy is keeping the star from collapsing. Once the star has gotten past the stage we would consider a protostar and formed into a, let's say, an average size star, the size of our sun, there is still a lot of gas and dust left over. Now, this gas and dust could do a ton of things. It could stay where it is. It could form together to form meteors, asteroids, or it can become planets over the course of millions and millions of years. Even our planet Earth was at one point gas and dust surrounding our newly formed star, grouping together into large clumps to form a planet. Now, of course, a planet is nowhere near the size of a star, so that can kind of give you an idea of just how much gas and dust was collected to form our sun. Now, you're probably wondering, well, what happens next? I mean, couldn't the star just continue this nuclear fusion process forever? Well, the problem with that is that the stars will eventually run out of hydrogen atoms to continue this nuclear fusion process. When this happens, when a star runs out of hydrogen atoms in its core, the star will begin to collapse in on itself. But this isn't the end of the star. While the star collapses in on itself, nuclear fusion is still going on outside of the star's core. This causes the star to expand in size to a red giant. As the star grows in size, and we're talking grows to an extremely big size, the star becomes increasingly unstable. Eventually, the star will come to its end. Now, what happens next depends on the size of a star. Our sun is not a large star, so more than likely when our sun meets its end, it will become a white dwarf. But that is not the case for all stars. If a star is large enough, say a supergiant or a very big red giant, it will eventually go through a supernova. Then, depending on its size, it could become a neutron star, or it could become a black hole. A black hole will only form if a star is exceptionally large. So you could have a star that's much bigger than our sun, yet even then it doesn't become a black hole. Instead, it becomes a neutron star. But if a star is unbelievably large, it will become a black hole. So, is this the end of stars? Well, no. No, the universe has been around for billions of years, and stars have come and go constantly, and they're still coming and going to this day. So, what happens next? Following the star's supernova, new clouds of gas and dust will be left behind. These clouds will be molecular clouds, and these will be the places for new stars to form. Stars are fascinating to learn about, and there's so much we can still learn about them that we don't know already. So do some research on your own, and of course, never be afraid to ask questions.